All right, test review number 8. So number 1, we're going to subtract the two polynomials, right? This is a minus sign in the middle, so it's subtraction. We're going to distribute the negative. And then combine like terms, the things that have the same variable. So minus 2x cubed and minus 9x cubed, which is, or is that minus 9? No, it's plus, my bad. Do it like this. Okay, so it's going to be 9 minus 2, 7x cubed. What else? X squared. So negative 7x squared. There's one x term. So plus 10x. And one constant, minus 3. So distribute the negative and combine the variables that are alike. Try it again. All right, combining the things that are alike. There's only one x cubed. There are 2x squares. So 8 minus 5. X and 4x makes 5x. And then one constant. Actually, I take that back. Two constants, 10 and 6. So 10 minus 6 is 4. Okay. 3 and 4 are the same way. So we're adding, so it's even easier. There's no need to distribute. So we're just combining like terms from the jump. So this is going to be 1x cubed term. So 16x cubed, x squared. 2 minus 1. One x term. 11 minus 5. 6. All right. Again, combining like terms. So there's 2 x cubes. So 2 plus 3 is 5 x cubed. X squared is only the 1. There's 2 x terms. So negative 3, negative 2, negative 5. And then 7 plus 8, 15. So combining like terms, since adding's ideal. All right, number 5. Hint, multiply it 3 times. Okay, so this is going to be 4x minus 2 cubed. Right, cubed. So what this is saying is four x minus 2 times 4x minus 2 times 4x minus 2. Okay, the best way to do this is to do 2 at a time. Like when you have 3, like, right? So like if you look between the difference between 5 and 6, right? They're identical for the most part. As far as procedures goes, you got to take 3 things and multiply them out. The only thing with 5 is that it's the same thing, 4x minus 2. Whereas in number 6, they're different numbers, but it's still three things being multiplied, and you can only do two at a time. So the idea is to use FOIL, first, outer, inner, last. You're going to multiply in this manner. So 4x times 4x, 16x squared, right? Multiply x's, you add the exponents. 4 minus 2, or 4 times negative 2 is negative 8x. Negative 2 times 4x is negative 8x. Negative 2 times negative 2 is plus 4. So this is going to be 16x squared. Combining like terms, right? 16x plus 4. Okay. We get a trinomial, right? 3 terms. We're going to multiply this by 4x minus 2. So notice, right? Notice, we did the first two, 4x minus 2. We multiplied them. We got a trinomial. Now we're going to take this and multiply it by the final 4x minus 2. So every term in one of these is going to have to multiply to each term in the other. So there's not really an acronym. Like FOIL doesn't necessarily work, but it's going to be FOIL-like, right? So this is going to be, look, I like to go backwards. That's just me. 4x times 4, 16x. 4x times 16 is going to be negative 64x squared. 4 times 16, again, plus 64x cubed. So 4x hit everything in the trinomial. Now the negative 2 times everything on this side. So this is going to be negative 8 positive 32x negative 32x squared. All right, so that's it. Now we're just combining like terms and write it in standard form, right? In descending order. So highest one, 64x cubed. X squared, negative 96x squared, x 48x, and then the constant minus 8. Okay. All right, 6 is the same way, except it's 2 different, or it's 3 different things now. But I can only do 2 at a time. So 3x plus 2, x minus 2. So using FOIL first, outer, inner, last. Combine like terms in the center. Okay, so there's my trinomial, and we're going to multiply by the last guy, x plus 1. So this is going to be x times everything. So negative 4x, negative 4x squared, plus 3x cubed. And this is nice because it's 1 times everything. And then combine like terms. So the largest degree, 3x cubed, square, negative 4 plus 3, negative x squared. The x's, negative 4. That's nice. Negative 8. And then the constant. All right. Oh, nice. Look, number 7. It's like what we just did, except done for us. So everything in one multiplies to everything in the other. So x times 2. X squared would be 2x cubed. X times 3x. 3x squared. X times negative 6. Negative 6x. 2 times 2 is 4. X squared. 2 times 3x. 6x. 2 times negative 6. Negative 12. Combining like terms. Highest one. 2x cubed. X squared. So 3 plus 4. Single x's. So negative 6 plus 6, that's actually nice because they cancel. Where negative 6 plus 6 is 0. And then the constant. All right, factor completely. So here I'm going to use the fact. Like I see this, right? And it's a cube. That's what jumps out at me first, is that this is a cube. Not only that, but I know that 64 is really 4 cubed. 27 is really 3 cubed. Wait, I mean, do you have to know that? I mean, it's kind of a requirement in doing this problem, right? Because the idea is that I want to apply a sum of cubes, right? When I see the x cubed, that's like the dead giveaway for a cubed minus b cubed. If you can see this, then this is going to be ab, a squared, ab, b squared. So the thing I remember, actually this is going to be a plus, right? Since this is a plus, right, a sum of cubes, I always remember plus minus plus. So plus minus plus. So that's what I'm trying to recreate. Okay. Rewriting it so that it looks a little bit nicer. This is going to be 4 cubed x cubed plus 3 cubed. Right, just rewriting it. And here you can see that the a, the first part, there's everything with the cube. Right, 4x. That's the a. That's this. And then the b is the 3. So everywhere there's an a, I'm writing 4x. Here, here, here. Everywhere there's a b, I'm writing 3. Here, here, here. And then simplifying in the end. So let's see. Just going to set it up. All right, so everywhere there's an a, I'm writing 4x. 4x, 4x, 4x. Everywhere there's a b, I'm writing 3. 3 times 3, 3 squared. Oh, and we almost forgot. This is squared. Right, because it's a squared. All right, simplifying this, we're going to get 4x plus 3, 16 because 4 squared, x squared, minus 4x times 3. 4 times 3 is 12. X plus 3 squared, which is 9. Okay, you might have to watch that one a couple times. The formula is pretty straightforward. A plus b, a squared, minus ab plus b squared. So we'll try it on the next one. So factor completely. factor GCF first. Okay, so I mean, if we didn't factor the GCF first, this is still a difference of cubes, but however, you would be able to factor one of those terms again. So here, noticing that everything's divisible by 8. So if you take out an 8 first, you're left with y cubed minus 8. Okay. So rewriting this, 8 is really 2 cubed. So how I write the formula. So watch how I write the formula. So I know it's A, B, A on the left, B on the right. A's are always on the left, B's are always on the right. So A squared, AB, B squared. So that's going to take some repetitions to practice, but AB, A squared, AB, B squared. A's are always on the left, B's are always on the right. All right, so now I need the symbols, right? This is a difference. So when I have a difference, I think minus, plus, plus, minus, plus, plus. So minus, plus, plus. And there's my formula. A in this case is y. B in this case is 2. So wherever there's an A, I'm putting y. Everywhere there's a B, I'm putting 2. So this is going to be, so look, y squared, y, 2 times 2, 2 squared. And then the symbols, minus, plus, plus. So it's not bad, right? Just putting it together. It's like a puzzle. So final answer would be y minus 2 this would be y squared plus 2y plus 4. Okay. Had you not factored out the 8 first, you would have got something completely different right here, and then you'd have to factor it again. But this is it, using a difference of cubes. All right. All right, number 10. 4 terms, so we're going to factor by grouping. So factor by grouping is a very specific technique. So if you split this down the middle in front of the second symbol, right, the second operation, the minus 30, so in front of the symbol, we're going to do it in pieces. So the left side, the 12a4 plus 2a cubed, I'm going to factor out the GCF. So the most a's I can take from both on the left is a cubed. Then coefficient wise, the biggest thing I can take from both of these is going to be a 2. So then what's left behind? We have 6a plus 1. All right, and if you check yourself real quick, if you try to factor it back in or distribute it back in, then everything's correct. Okay, for factor by grouping to work, I know that this side needs to have 6a plus 1. Like it has to. So what can I factor out of the right so that 6a plus 1 shows up? This is going to be a negative 5, right? Because when I try to put it back in, this is negative 5 times 6, which is negative 30. So we're good there. And then again, negative 5 times 1, negative 5. So this is good. All right. 6a plus 1. Because they match, we can proceed to write this down below. And then the outside piece is 2a cubed minus 5. All right, then we check one more time to see if maybe a difference of squares or a difference of cubes, but no. Can't go any further. Final answer. All right. Number 11, x4 minus 64. Okay, so when factoring this, this is almost like a difference of cubes, right? The only thing is that is an even number. So when it's even and it's two terms, usually a difference of squares is what works here. So this one's going to look like this. So a squared minus b squared. I can rewrite it as a minus b, a plus b. That's what I'm trying to do here. So I just got to identify the a and the b. So it's minus. So that's the first part. So that's another indicator. Also knowing that 64 is really 8 squared. All right. The x to the 4 can be rewritten as x squared squared. So anytime you have a difference of squares, you're always trying to take out a square from the exponent, a 2, essentially. Right? Because when you have a power raised to a power, you multiply. So the a in this case is x squared. The b in this case is 8. So this is going to be so a minus b, a plus b. Right, that's exactly what we're trying to make. A and then b. Right, a minus b, a plus b. There it is. All right. 12. Trinomial, slide and divide. That's the clue here. Okay, so technically slide and divide really isn't going to work because there's nothing to slide, right? Like if you know this technique, you slide the a over and then you try to factor it. Well, that's not necessarily the case here. This is just, so a to the 4 and a squared. So these terms are bigger than what we're used to dealing with. However, because the middle term, 2, is half of 4, this thing will behave like any quadratic would, right? Like if this was a quadratic, a squared plus 5a minus 14, then we could factor it, right, using traditional methods. Well, because it follows a pattern where the middle term is half, right? Because if this was a squared and then 1, essentially there'd be nothing. It follows the pattern is what I'm saying, right? So if this was a 6 and this would be a 3, then we could do what we're about to do. If this was an 8 and this was a 4, then we can do what we're about to do, right? As long as that middle term is half of the first term, exponent that is, then this will behave like a quadratic. So what I mean by behave like a quadratic, if this was a quadratic, we would say, what two numbers multiply to make 14 that add up to 5? 1 and 14, 2 and 7. And we look to see, okay, negative. So I want it to be positive, so the small one needs to be negative. Okay, so not this one. Right, when you multiply, it makes negative 14, but when you add it up, it actually makes 13. This is the guy we want. Negative 2 and 7. That adds up to 5. Also multiplies to make negative 14. So normally in a quadratic, you would say, okay, got my two numbers. They drop right into the factors. A minus 2, a plus 7. However, this isn't just any quadratic. It's a 4th degree polynomial. So what we're going to do is, whatever that middle term is, that exponent, that's what these get. That's what they get. So if this was like, for instance, example, if this was like 8 and then this was 4, well, then the A's would get a 4. Right? If there was 10 and 5, then the A's would get a 5. So it's always the middle term. Always the middle term. Okay. sum of cubes. We literally just did this on the last page. So this is going to be sum of cubes. So I'm seeing plus. So right away I'm thinking plus minus plus. So I already know how the A's and the B's like form up, the formation that they make. And then these are the symbols that'll go in between the A's and the B's. Plus minus plus, because it's a sum. All right. So I'm just going to write that down. Watch. AB. A's on the left. B's on the right. And now the symbols go in plus, minus, plus, because it's a sum. Because it's a sum. Okay. 8 can be rewritten as 2 cubed. 2 times 2 times 2. X is already cubed, naturally. And 27 is really 3 cubed. So knowing your cubes really comes in handy. The A in this case is 2x. The B is going to be 3. So now we know my A, we know our A, we know our B. We just drop them into the formula. But they're going to get squared. So this is going to be 2x. 2x. Remember, you have to square the whole 2x. 2x. And then 3 times 3. 3 squared. Okay. Simplifying. Final answer. 2x plus 3. 2x squared is 4x squared. Right? 2 squared is 4. X squared is x squared. 2 times 3, 6x. 3 squared is 9. Final answer. All right, 14. This is, I see 2 terms, I see a minus sign, and I see a square. Like these are all the indicators for a difference of squares, a difference of 2 squares. So I'll write it again. A squared minus B squared. I'll write it over it. So if we can recognize A squared minus B squared, if I can recognize that, then I can go straight to A minus B, A plus B. So the obvious one is the X. That's A. The next is not so obvious, but 16 is really 4 squared. So the B is 4. So we know our A, we know our B, straight to the formula. X minus 4, X plus 4. Okay. All right, 15. So really, 15, the hint for 12, trinomial slide and divide, that's what we're going to do right now. So this is definitely a slide and divide scenario. For those of you that don't know the technique, what we do is we multiply the 6, right? The A term, right? The x squared term, right? This is A, B, and C. When A is something other than 1, there's a technique of sliding it over by multiplying and creating a brand new quadratic. 6 times 3, or negative 3, is negative 18. So this quadratic will have the same roots as the above quadratic. So now, if we do our little X method, numbers that multiply to make 18, that add up to 7. So there's 1 and 18, 2 and 9, 3 and 6. So somehow we need to somehow make a 7. And not only that, but it needs to be negative 18. So the big one has to be negative, 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 negative. All right, the first one, nope. This one's good, and this one's trash. So what this is saying is that x plus 2x minus 9 are factors. However, it's a slide and divide method. So if this was the slide part here, now comes the divide part. So the way the divide part works, you divide by 6. Reduce as much as possible. And then if there's still a fraction, you take the denominator and you move it up in front of the x. I know it's like some voodoo that's happening right now, but this is the technique, right? So this is going to be final answer. 3x plus 1, 2x minus 3. Because if you FOIL this out, you would get 6x squared plus 7x minus 3. All right. Okay, 16. Divide by using long division only. Okay. All right, let's do the long division thing. So this is going to be 2x minus 8. That's the divisor. The dividend, the part inside, 4x cubed minus 8x squared plus 32x. All right, so we look to see if all of the terms are there, right, in descending order, standard form. X cubed, x squared, x. There's no constant. That's okay. So now we look at the leading terms of the dividend and the divisor and say, what do I multiply 2x by to get 4x cubed, right? 2x times what gives me 4x cubed? This is going to be 2x. So when you, or 2x squared rather, I'm sorry. So now, when you have what you believe is the answer, you distribute. And then you write them here. So 2x squared times 2x is 4x cubed. And that makes sense because you want them to match, right? You want them to match up at this moment. And we line up the variables correctly. So then this is going to be 2x squared minus 8 would be minus 16x squared. Okay, so now there's a couple different ways that this is taught. I personally, normally we're supposed to subtract in the division process. Right now you subtract, which is true. We do subtract, but we're subtracting a binomial, a polynomial. So the negative is going to have to distribute, right, to everything inside, which means this is now negative and this is now positive. And now we add. So basically you flip the sign of everything in that bottom row. Minus turns to subtraction turns to addition, and then all the signs flip, right? So we're essentially distributing and combining like terms. So this is going to be 0, right? Because 4 plus negative 4. Negative 8 plus 16 is 8x squared. Then we bring down the 32x. And we say 2x times what gives me 8x squared. And this is going to be plus 4x. Now I have to distribute the 4x to everything over here. So this is going to be 4 times 2, which is 8x squared. Again, the x squareds match. So that's how I know I'm doing, or not the x squareds, but this term matches. 4x times negative 8. Negative 32x. Okay. So I know it's subtraction, but I'm going to add and flip all the signs. This is going to now be minus. This is now plus. And then we're adding everything. Right? We're adding everything. So this is 0. This is going to be 64x. All right, there's nothing else to bring down, right? We're essentially done. So this is the remainder. So the way we write our answer, the quotient, right? 2x squared plus 4x, and then plus 64x over 2x minus 8. Okay. All right, number 17. This is everyone's favorite, synthetic division. So here we look to see x minus 3. So in the box, I know I'm going to put positive 3. And we grab the coefficients. So again, descending order, all terms accounted for. So this is x to the 4th power, the coefficient of 1. There is no x cubed term. So I have to put a 0 because x cubed is missing, right? X cubed is missing. All right, negative 13 for the x squared. 0 because x is missing. And then 32. So we bring down the 1. And start the process. 3 times 1 is 3. Plus 0 times 3. Plus negative 13. You add, you always add. So this is negative, was this 4? Is that true? Yes. Okay, times 3 is negative 12. Times 3 is negative 36. Which is negative 4. Okay. It was an x4 was the leading term. So the result is always 1 less. So the answer, x cubed plus 3x squared minus 4x minus 12. But what's up with this negative 4? That's the remainder. Negative 4 over x minus 3. You could write it like this. So you might need to watch that a couple times. Okay. The length of a rectangular prism is x plus 3. The width is 2x minus 1. And the height is x plus 8. Which expression is the volume? Okay, so basically we're going to find the volume. Length times width times height. So this is like what we did on the front page. So there's 3 things, right? X plus 3, 2x minus 1, x plus 8. So we're just going to FOIL all these out. Doesn't matter the order. That's a minus 1. Okay. X times 2x, 2x squared. X times negative 1. 3 times 2. 3 times negative 1. Combine like terms. We get 2x squared minus plus 5x minus 3. Okay, this guy times x plus 8. So again, everything on one times everything in the other. I like to go from the 2 to the 3. That's just how I like it. So negative 3x plus 5x squared plus 2x cubed. 8 times 3, negative 3 is negative 24. Plus 40. X plus 16x squared. All right, writing these in standard form, descending order, combining all the like terms. There's only one x cubed, 2x cubed, x squared. So 21, x squared, x 40 minus 3 plus 37x, and then the constant, negative 24. So here's the formula for volume, length times width times height. All right, 19. Solve by factoring. Hint, rewrite so that all terms are together. Okay, so basically, we're going to solve by factoring, but we got to move everything to one side. So plus 9x, plus 9x. Everything's on one side. So now this is going to be 2x to the 4 minus 3x minus x cubed minus 18x squared plus 9x equals 0. So the difference here is that this is equal to 0. So our final answer will be x equals a number, right? X equals a couple numbers probably. All right, so we're going to solve by factoring. Again, it's 4 terms. Factor by grouping. You split it in front of the operation, right? The third term, second operation. All right. I can take x cubed from both of the terms on the left. What's left behind? 2x minus 1. Okay. For this to work, 2x minus 1 must show up on the right. So what do I factor out from the right side to leave me with 2x minus 1? So this is going to be a negative 9x. Right, when you try to put it back, say negative 9 times 2, negative 18x squared. Negative 9 times negative 1 is positive 9x. So it's all there. Okay. These match, so we are good to proceed. 2x minus 1. Right in the leftover parts. x3 minus 9x. Okay. So check it out. Here, normally you'd be done, but you always check to see one more time if you could factor anything out. And I see that right here, we can factor out an x because there's something common. There's a GCF, right? A greatest common factor to both x cubed and minus 9x. So this is really going to be x squared minus 9. 2x minus 1 is still there. So 2x minus 1, factored out an x, and x squared minus 9. Okay. I'm going to, because this is all equal to 0 at the end of the day. Right, this is all equal to 0. So when it's equal to 0, you set each term equal to 0. 2x minus 1 is equal to 0. X is equal to 0. X squared minus 9 is equal to 0. So plus 1. 2x is equal to 1. Divide by 2. X is equal to 1/2. That's one solution. X equals 0. Second solution. The last solution, we add 9. X squared is equal to 9. Undo the square root. So x is equal to, anytime you have a square root, you got to put plus or minus. And then the square root of 9 is 3. So we actually have two answers. X plus 3, x equals plus 3, and x equals negative 3. So we have 4 solutions. 1/2, 0, negative 3, and positive 3. All right. Use the following scenario for problems 20 and 21. Sales of number of refrigerators, dishwashers from Home Depot during the calendar year, where X is the number of the month, can be modeled by. Okay, sure. So R is refrigerators, D is dishwashers. Too easy. So now, which function can be used to model total sales? So all we're going to do is add R plus D. Right, we're going to combine like terms. And there's decimals, great. So this is going to be 0.7 combined with negative 1.2. So basically minus. So 7, 8, 9, 10, 11, 12. So 0.5. So negative 0.5 x cubed. Right, all we did was combine these two by adding 0.7 plus negative 1.2 squares. So negative 4 plus 8 is plus 8 x squared. The x's negative 44 plus 94. So 54, 50 x. And then last is the constant. 3 minus 13, negative 10. Okay, so this right here is the function that can model the total sales of both refrigerators and dishwashers. Too easy. So now we want to figure out the sales of June. So June is the January, February, March, April, May, June. It's the 6th month. So we're going to plug in 6. Everywhere there's an X. Okay. Get my handy dandy calculator. Please be charged. Otherwise, I have to do this by hand. Yes, it is. So I'm going to plug it in exactly how I see it. Using parentheses exactly how it's written. I don't know if you can see this. $470. Let's go. Total sales $470. All right. Last page. Let's go. Another long division. Okay. So here there's a missing degree in the divisor. So there's going to need to be a 0x in the divisor. So x squared plus 0x plus 1. Okay, 7x cubed plus 11x squared plus 7x plus 5. And all of them are there. All the terms. 3, 2, 1, constant. Okay. X squared times what gives me 7x cubed? 7x squared. Correction, 7x. So now 7x distributes to everything and gets written underneath, lined up with its appropriate exponent. So 7x times x squared, 7x cubed. 7 times 0, that's actually nice, 0. 7 times 1, 7x. Okay, we need to subtract. However, the way I teach, we're going to change all the signs, so we're going to add. This is now minus, this is now minus, and this is now minus. So when you combine, this is going to be 0, like a 7 minus 7. 11 minus 0, 11x squared. 7 minus 7 is 0. So 0x. And then bring down the 5. Okay, start the process over. X squared times what gives me 11? This is plus 11. Distribute the 11 to everything. 11x squared, and matches, we're all good. 11 times 0, which is just 0, you don't really need the x. And 11 times 1. Again, we're supposed to subtract, but the way I teach is we add and we flip. Add and flip. So 0, 0. 5 minus 11 is negative 6. Final answer, 7x plus 11, negative 6 over x squared plus 1. You didn't need the 0 in between x squared and 1 this time. It's only during the actual division process. I guess you could put a plus right here. You could put the minus there too. It's the same thing. Just, if you can get here, I'm happy. Right, remainder over divisor. Remainder over divisor. Just remember that. Okay. 23. Create a polynomial that has solutions. X equals negative 2, x equals 0, x equals negative, or x equals 4. So going backwards. Yes, going backwards. We start with the roots, right, the solutions to the problem, where it crosses the x-axis. And we got to work our way backwards to an equation. So, I mean, the hints are all here. Set the factors up. So we turn the roots into factors. So this x plus 2, we always teach the inside lies, right? Inside lies. So x equals negative 2. So that's exactly what happened here, right? X equals negative 2 to force the inside to lie, x plus 2. All right, x equals 0, that's easy. X minus 0. And then the last one, x equals 4. So x minus 4, right? Inside that's the lie. X minus 4. All right, you can simplify the middle one, right? X minus 0 is just x. So now, what this is saying, we FOIL it all out. So I'm going to do x plus 2, x minus 4. I'm going to FOIL this out first. Where I'm going to do this one and this one first. Just because I can run an x through the end, like real easy like. So this is going to be x squared minus 4x, enter, plus 2x, last, minus 8. Combining the middle two, x squared minus 2x minus 8. And now we're going to multiply all this by x, right? Because that's the middle one. The middle one has to be multiplied. So I'm going to run the x through everything. So x cubed minus 2x squared minus 8x. Okay. 24. What is the degree of the polynomial? So you got to look at the largest exponent. 5. Rewrite in standard form. So standard form is going to be decreasing order. This one's actually really important, actually. So this is negative 9 x to the 4. That's the biggest one. Minus 6x cubed minus 2x plus 6. Okay. Constant. Which one's the constant? Which one has no x on it? The constant is 6. The leading coefficient, that's the term, or actually it's the coefficient on the term that has the largest degree. So that's this guy right here. So negative 9. because x4 was the largest degree. It's the leading term. So I want the leading coefficient, which is -9. And how many terms are there? There's 4 individual terms. There's 4. All right, man. Hopefully this gets to you in time. Good luck. Catch you guys in the next video.